Hi, hello friends. Welcome to my YouTube channel. Thank you for your views and comments and subscriptions. We'll continue our SSC JEE 2011 Electrical Solutions Part 8 here. If the discharge voltage of a thyroid arrestor, as you can see here, this is a thyroid arrestor as you see in here. These are the thyroid arrestors is 373 kilovolts RMS and the rated voltage is 211 kilovolts RMS. The discharge factor of the arrestor is, so here the discharge factor DF is nothing but discharge discharge voltage. So it's a peak divided by rated RMS voltage. So this is discharge voltage. How much discharge voltage is nothing but 373 kV, but it should be in peak value. So they are specified as a RMS. So we can convert into peak value as with the multiplying of root 2 here divided by rated RMS voltage. How much rated RMS voltage is nothing but 211 kV. If you solve this, you'll get as 2.5. The answer is 2.5. D is the right option. The next question is, during the arc extinction, SF6 gets decomposed into SF4 plus, and SF2, decomposed into S and F ions, reduced to SF2, oxidized here. As you can see here, when the contacts are closed here, circuit breaker, here we have SF6 gas here. When the contacts are getting opened here, the SS6 is getting decomposed into SF4 plus SF2. That means it is divided into two parts. That is decomposed into SF4 and SF2 is the correct answer. The next question is, which of the following is true? The load factor is equal to capacitor factor into utilization factor, or utilization factor is equal to capacitor factor into load factor, or capacitor factor is equal to load factor plus utilization factor, or capacity factor equal to load factor into utilization factor here. So before going to discuss here, what is a load factor? Load factor is nothing but it's a ratio of average demand by maximum demand, and planned capacity factor or capacity factor is nothing but it's a average demand by installed capacity. Now what is utilization factor? Utilization factor is equal to maximum demand by installed capacity. So we can say that the capacity factor is nothing but average demand by installed capacity, which is can be written as average demand by maximum demand into maximum demand by installed capacity. So average demand maximum demand is nothing but load factor into MD, that is maximum demand by installed capacity, nothing but utilization factor. So capacity factor is equal to load factor into utilization factor is the right answer. The next question here is, an electric load consumes 17.32 kilowatts at a power factor of 0.707 lagging. For changing the load power factor to 0.866 lagging, the capacitor that is to be connected in parallel with the load should draw. That means we can say compensation. So QC is equal to the total power in kilowatts into tan phi 1 minus tan phi 2. This is standard formula here. The first case, what is the power factor? 0.707. So cos phi 1 as 0.707. So that phi 1 is how much? That is 45 degree. That is 1 by root 2. Next, similarly, 0.866. So cos phi 2 is nothing but 0.866 is nothing but root 3 by 2. So where phi 2 we can get it as 30 degrees. Now QC is equal to how much power? 17.32 kilowatts into tan 45 minus tan phi 2 value is how much? 30 degrees. If you substitute this, you can get the answer as 7.32 kVAR as the answer. The answer is A. The next question is, the most appropriate way of mitigating the problem of interference between the power line and the communication line is to transpose the power line, transpose the communication line, use double circuit power line, use bundle conductors power line. So as you can see here, we can transpose the conductors or power line to reduce the interference effect between the power conductor and the communication system here line like this. So suppose this is a communication line is about a telephone line here. So for that what we are doing, we are interposing here. Suppose if you observe here, this conductor is transposed to down like this, and the blue line is a top. You can keep it as a blue line here only, and we can change the lines like this. So the answer for this one is the transposer power lines, and the next best option is use a bundle conductors in the power line here. So thank you friends, thanks for watching my videos. If you like my videos, please subscribe and comment and share. Have a nice day.